Boom. All right, let's go. Kinsey, would you care to help me out on number one of our homework here? We're trying to decide how angle 8 and angle 4 are related. What kind of angles do we have here? She's saying corresponding. Jake, do you agree? Yep, check it out, guys. 8 and 4. They're not same side interior. They're not alternating. These are the same angle. They just happen to have one on the outside and one on the inside. Yes, thank you very much, Kinsey. How about, let's go, David. Number 2, man. Kind of a similar situation here. We're trying to figure out which set of these angles are corresponding on number 2. Say it again. Yeah, there again. We've got 8 and 16. Once again, one on the inside, one on the outside. Hey, Ted. Oh, you're part of my video now. Tail was late. All right, sorry, I had to add that in. Number 3, let's go. How about Ethan? Which one of these statements is true on number 3? I know it's kind of frustrating to have to look at angles this way. It's always easier whenever they just give you a number. Yes, it's going to be B here. These are alternate interior angles. Yeah. There we go. I had it frozen, yeah. Because we can see that one is right here and one is right here. Okay, how about last one? We got a little bit of algebra action. I like it. That was always my favorite. Let's go. Press. Help me out. How would you solve number 4 here?
Well, you subtract 19 from both sides.
And by the way, I noticed that some of us on our test, the reason we missed the problem wasn't because we didn't know how to do it, but because we messed up on our algebra. So never hurts to get a little bit of practice in, because I do it too. I mess up on algebra all the time.
And then that equals 2p over 3 to the negative 4.
Yep.
And then you multiply by 3 on both sides.
I love it. If you have a fraction, the way we destroy that fraction is by multiplying by the denominator. Yep.
And the 2p.
Nice. Very good. Hopefully that was a little bit of an easier one to end on, right? A little bit of freshman year throwback for those of you who are sophomores. A little algebra 1 throwback. Glad that last year's class paid off. If you hadn't been able to do that one, I'd be a little bit upset at myself. Any questions, guys, on any of those 4 here? Just want to make sure before we jump into a brand new lesson. Anything at all? All right. Well then, guys, I think you're really going to like day 2. Day 2 is a little bit of reinforcement from what we learned on day 1. Not a lot of new stuff. It's more incorporating what we learned on day 1 and putting some algebra in there, using it to solve some real-world problems, using the angle relationships that we have to handle any kind of situation. So real quick reminder, let's go, Hunter. Would you care to remind us about the 5 kinds of angle relationships that we have?
Corresponding, inside exterior, inside exterior, alternate interior, alternate.
You got it, man. Those are the 5 right there. If you get down these 5 for this chapter, you're going to be in very, very, very good shape. And the good news is that a lot of times it's pretty easy to see which one we're dealing with. So what I'm going to let you guys do is I'm going to pause and give you guys a chance to try 1 through 6 on your own here. Give you a chance. Take about the next 2 minutes. See if you can just label what these 6 are. I think this will be a good review for some of you guys who were labeling. So let's go. How about Lucas? Help us out, man. What are you thinking for number 1?
Transversal.
Well, that is what this is right here. This is our transversal. But what kind of angles are Y and X? Corresponding, yes, sir. Crazy corresponding. That's what a name. How about Jack? What do you think for number 2?
Alternate exterior.
Yep, they're on opposite sides of our transversal, and they're on the outside of the parallel lines. I like it. Alt, and you guys can abbreviate. just like we did in the last chapter. You don't have to write all this out. How about number 3? Let's go. Jake, what are you thinking for number 3, man? Thinking corresponding? I agree. Here's how we know. One's on the inside, one's on the outside, and they are on the same side of the transversal. How about number 4? Let's go. Lily? Ooh. Now, this is one a lot of people forget. Are these on the same side of the transversal? Are they also on the interior? Maybe thinking same side interior? That's one that even me, I forget that one sometimes when I look at it. It takes me a second to be like, wait a minute. Oh, yeah, that exists. What's up, Jacob? Sure, man. Yes, sir. Alternate interior. That's one you see. That's one you'll probably see the most in this entire chapter is alternate interior. How about Justin? Finish this thing off, man. Number 6. Alternate exterior. So really, guys, that's not too bad at all. Just kind of those 5 identities, understanding what they are, because 4 out of these 5 are congruent. 4 out of these 5, we can say, okay, if we have this, that angle's that angle. They're the same angle. So what I'm going to let you guys do, just take, these are all very, very similar theorems and postulates. I'm not going to make you guys read them out. I'm not going to make us read it back. Just take a minute to just kind of read over them and see if it makes sense and checks out with what we've been talking about. Just these 5 theorems and postulates. Like, for example, on number 1, alternate exterior angles, would you say that maybe angle 1 and angle 8 could be alternate exterior? So we would say angle 1 equals angle 8. Yep. So again, you may have chosen a couple different angles than I did, but hopefully your angles kind of meet that same criteria on these first 3. 3 and 6, 4 and 5, 1 and 5, 3 and 7 are all congruent. Big thing here is, though, Angel, what do we know about same side interior angles? Are they congruent or something else?
There's something else, like if you add them both together and then you can.
Sure. Give me maybe an example of angles that are same side interior here.
4 and 6.
Sure. 4 and 6. So if you do 4 plus angle 6, you said that's going to add up to be 180. Yeah, they're supplementary, guys. Mm-hmm. Good old definition of supplementary angles. Add up to be 180. Little throwback to chapter 2. How about this one's kind of weird. David, would you kind of just read us maybe number 5 real quick? So in other words, if we have 2 parallel lines, guys, and a line cuts straight through one of them, would it make sense that if that makes right angles, that if it cuts through a line right underneath, if it's also parallel, it would also create right angles? Yeah, because it's literally hitting virtually the same line. This line and this line are virtually the same. So yeah, of course it's going to make some right angles. What's up?
Would it be an angle plus an angle equals 90?
An angle plus an angle?
Yeah.
That would be if we made a line like this, Jacob. If we did that and we said, hey, we've got a line right here, a ray, we could say that angle plus that angle would equal the whole 90 degrees, but they don't actually give us that. So that's not really something we're going to see for this just yet. And so, guys, what I'm thinking honestly, we can probably skip over. I trust you. I mean, you're my accelerated class. I'm going to give you a few seconds here. Look over the top part of this next page. But honestly, I think you guys can label. I'm not going to make you necessarily do this unless maybe we really feel like we don't understand what these concepts are. The vertical angles, linear pairs, supplementary. I know you guys know that angle 1 and angle 4 are vertical. I know you know that angle 1 and angle 2 are a linear pair. They add up to be 180. I know you guys know that angle 1 is congruent with 4, with 5, and with 8. That's really maybe the only one I would want to look at. Look at number 3 for me, guys. When it comes to angle 1,
why is angle 4, Riley, why is angle 4 congruent to angle 1? What kind of angles are these?
Vertical.
Yep, so angle 4 because of vertical. How about Jack? Why is angle 8 congruent to angle 1?
Juniors and seniors,
Yes, sir.
last name H through K. Juniors and seniors, last name H through K.
How
Report
about
to the auditorium.
why is Bree? Why is angle 5 congruent to angle 1? What kind of angles? I'll give you a second here, Bree.
Sorry, I think
They are congruent because they are what kind of angles? 1 and 5.
they're same. No, they're 80.
I think Jack may be onto it there. These angles, they're on the same side. One's on the outside, one's on the inside. Pretty sure those are corresponding. Yep. So, just a little reminder there, guys. That's why we know those three are congruent. One's vertical, one's alternate interior, and one because of corresponding.
Is that 5?
It is. Yep, angle 5. Sorry about that.
And not
Yeah, you're good. Yep. And so what I'm going to let you guys do, what I like about these is these are kind of like dominoes. Whenever you find one, whenever you're given one angle, everything kind of falls after it because you can start to make some connections here. So what I'm going to let you guys do is I'm going to let you guys partner up if you'd like to, or you can work solo. And I would like you guys to try the bottom half of this page for me. What we're going to do is, check it out. We're giving, these go really, really quick. They give us an angle. Angle 3 is 102. Can we maybe see why this thing would go pretty quick? Because if that's there's only two kinds of angles, guys. There's going to be 102 angles, and there's going to be angles that are supplementary to that. So 78. So I'm going to let you guys do your thing on these two parts right here. You can work solo or with the partner. So for example, I know that's 78. These are linear
So
pairs.
you just have to look where the angle, each thing is at angle.
Yeah, I mean, honestly, what I would do is I'd write down the number right next to the angle. Like that. I already have, literally, I can already have this whole corner right here. If that's 102, that's 102. These add up to be 180, so that's 78. If that's 78, these are vertical. That's 78. Yeah, so you can literally fly through these.
Do the bottom.
Yep. Yeah, we'll do these two right here. And then we'll just have one page left, guys. So you're ready to wrap up. There's just going to be some multiple choice on that page 4, kind of like we had in day 1. Here is our first one there. Don't forget, if you need to, you can turn the page. And boom, you got a transversal that's cutting through that parallel line and that parallel line. So all of a sudden, you can do the same thing we did with the first one. Just double check that. So just kind of clusters of 102 and 78. I got you. Boom. So angle 9 we know is 80 degrees. Sweet. Angle 5 we know is 68 degrees. What do we know about this cluster up here, guys? What's that going to mean angle 10 is? 100. Remember, Jack, these are a linear pair, aren't they?
Oh,
That angle plus that angle adds up to 180. What's that going to mean for angle 12 and angle 11? Do we have some vertical angles there? So that's 100. That's 80. How about this cluster down here? Can we literally do the exact same thing? If that's 68 degrees, what's that going to make 6? 112. And again, vertical angles, that's 112. That's 68. And you can kind of see how things would spread here. If that's 80, and angle 2, these are same side interior, what does that mean angle 2 is going to be? What adds up with 80 to be 180 degrees? Hundo.
Yeah.
And if that's a hundo, what's that going to mean for angle 1? 80. Also, aren't angle 1 and angle 9 corresponding angles? Yep, so those are going to be the same thing. And you guys know from here, you can do the exact same thing for this quadrant down here. 1012, that'd be 68,
Say 112.
or 112. Close, but no cigar.
So what is the extra angle that you're talking about?
These out right here. Check out some real world probs down at the bottom. We're going to hop down to the one about fencing and the one about zip lines. This will be where we close today. So I'm going to let you guys read over number 1. Let's read about this fencing section. Anybody in here ever helped fence in, like maybe a pin or anything like that? A few people? Okay. Sweet. That's awesome. That's something that I've only done a couple times. It's tough work. I hate putting in fence posts. It sucks. This one's pretty darn short. What kind of angles do we have here, Press? What are you thinking for number 1 about fencing? Fantastic. Yeah, go ahead, Jack.
She said she didn't know.
Yeah.
Oh, those are alternate interior, I think.
You know, let's see. Now this is 50. Wait a minute. This is 50. What does that mean that this right here is going to be?
Oh, they're vertical angle.
Aren't those vertical angles?
Yeah.
So if that's 50, that means that's 50. Now wait a minute. You're good. Turn this thing.
Juniors, O through R. Juniors are the last name, O through R.
Now wait a minute. If that's 50, aren't these same side interior angles?
Same size, isn't it?
They're on the same side, aren't they? Of this transversal? They're both on the left side. Check this out. If these are both on the left side of the transversal, here's our parallel line, here's our parallel line. What's that mean that's going to be? Won't be 50.
Both of them are very bad. Why is there a Y in the figures?
The Y is what we're trying to find.
Y is 50, isn't it?
It's not 50.
Where'd you pull that 50 out of?
You told me these are vertical angles, didn't you? Also, if that's 50 degrees, that's 50 degrees. These are vertical angles.
Oh, okay.
And so if those are vertical angles, these are not connected. So if that's 50, we know that these two have to add up to be 180. Right? Same side interior?
Yeah.
So if we have same side interior angles, what would that mean Y is? It's not going to be 50, it's going to be 180 minus 50, aka 130. That's all right. That was a good one to work through. I'm glad we got a chance because that one can be a little deceiving. Yeah, those aren't alternate interior angles.
That would hurt my brain.
Well, because remember, isn't this a parallel line, Jack?
Looks like it.
Isn't that a parallel line?
Heck, yeah.
50's on the outside, isn't it?
Yeah.
It's on the exterior. Y's on the inside. These aren't alternate interior.
Okay, well.
This would be alternate. That and Y would be
Oh, I
alternate
get it
interior.
now, 'cause they just, never mind.
Yeah, these will be the same.
It was a
You're good, man. Yeah, that would be 130. Last one. I'm going to let you guys try number 2 all on your own here. And then we will be done for the day. Homework is on day 4. It's on page 4.
well, I'm sure it is.
So once we get done with number 2, just a reminder, H-Dub on page 4. By the way, that 75 degrees belongs to this part right here, if you're a little confused. It's below that transversal. And if it helps, you may want to twist your paper 90 degrees. That may help you see this this picture a little bit better. What's up? Well, it's about 75 and 1. Well, they're on the printed paper. Here's the transverse. Aren't they on the same side and on the interior? So I don't think those will be corresponding. Yeah, the best way I think you could help yourself on this one is turn your paper. And if you need to, you can draw lines through these trees to help you out. So,
Oh,
let's play this out here. Let's go. I'm calling almost everybody today. Dang. Say it. What are we thinking as far as, I'm going to skip down to B. What kind of angles are 75 degrees in one? Well, are they on the same side of the transversal? Are they on the left side? Are they on the interior? So we may be thinking maybe same side interior. Yeah. And if they are, Ethan, help us out, man. What does that mean? This angle one's going to add up to 75 degrees.
S through Z, come get your picture taken.
That's right. That means 75 plus angle one's got to be 180. So 105 degrees. Yep. The same side interior, they have to add it to be 180. So thank you guys very much. If you have any questions, I'll be around to answer them. If not, you go be packing up. Remember, page 4 is your homework. It is, I think, 5 multiple choice questions.